This is my third video lesson for Unit 13. In this lesson, we'll be analyzing strong and weak acids and bases and their conjugate pairs. Go to page 12 in the class packet. We're first going to analyze why acids and bases are considered electrolytes. Electrolyte is a substance that when dissolved in water conducts electrical current. If you recall from last term, in order for anything to conduct electricity, electric charge must be transferred by physically moving charged particles, either mobile electrons or mobile ions. For acids and bases, when they dissolve in water, they dissociate to form mobile ions in aqueous solutions. This allows the acids and bases to conduct electrical current, as you can see here. Learning check number 1. Which species can conduct an electrical current? Pause the video and resume as completed. So you're looking for acid and base that's aqueous, dissolved in water. The answer is choice 4. This is acetic acid on table K and is aqueous. Learning check number 2. Which of the following aqueous solution is the best conductor of electricity? Pause the video and resume as completed. The answer is choice 4 because it has the highest concentration and sodium hydroxide is a base. Learning target. At the end of the lesson, I'll be able to analyze strong and weak acids and bases and their conjugate pairs. Homework will be number 3, which will be a Junipod based off this lesson. There will be a quiz Junipod on PowerPoints 1, 2, and 3. What does it mean when an acid or base or an electrolyte is strong or weak? Let's first start with non-electrolyte. Non-electrolyte is when there's no ions in solution, therefore it does not conduct electricity. So here's an example. Here we have sugar dissolved in water. Sugar is a non-electrolyte. As you can see from the chemical equation, the molecule does not break up into ion. The molecules stay as molecules. If there's a non-electrolyte in this solution, electrical current will not pass through the solution. As you can see, the molecules do not break up into ions. Therefore, electrical current cannot pass through. Another example of non-electrolytes are alcohols. Alcohols are a class of molecules. If you recall from the previous lesson, there are covalent compounds with OH groups. Here are 2 examples, methanol and ethanol. For strong acids and bases or electrolytes, they would dissociate completely, 100%, or the molecules will become ions. So here's an example. We have HCl aqueous. This is a strong acid. It would dissociate completely. So you only have hydrogen ions and chloride ions. Therefore, strong acids and bases conduct electricity very well. As you can see, the light bulb got very bright. This is because the molecules of the acids and bases in electrolyte dissociate completely. For weak acids and bases, they only will dissociate partially, less than 100% in water. Some molecules become ions and there is equilibrium. So here's an example. We have ammonium aqueous. So this is a weak base. It will dissociate into ammonium and hydroxide ions. So there is an equilibrium. So there is a mixture of each substance in the solution. So the light bulb will not be as bright as a strong acid and base and electrolyte. This is because the weak acid and base and electrolyte did not dissociate completely. There is a mixture between the molecules and the ions. Keep in mind, weak acids and bases are still dangerous at high concentrations. So here's a summary of what we just talked about. For non-electrolytes, no molecules form ions. For strong acids and bases, you have all the molecules forming ions. It dissociates 100%. And for weak acids and bases, there is equilibrium. Some of the molecules will form ions and there's some partial dissociation. Why do strong acids and bases produce a brighter light than weak acids and bases? This is because strong acids and bases have more mobile ions than weak acids and bases and will conduct electricity better, as you can see from these diagrams. Here is a summary concept map of electrolytes. Here are the 7 strong acids and 8 strong bases. You have to memorize these. Out of these 4 binary acids, only HF is a weak acid. The other 3 are strong acids. On the regions, they commonly ask hydrochloric acid, sulfuric acid, and nitric acid. For strong bases, there typically are ionic compounds with hydroxide that is soluble. Learning check number 3. Which formula represents a compound that is a strong electrolyte? Pause the video and resume as completed. A strong electrolyte is a strong acid or base, so the answer is choice 4, because that's nitric acid. Question number 1, is magnesium hydroxide a strong base? Notice that this one was not in the 8 strong bases. This is a weak base. If you check table F in your reference table, magnesium hydroxide is not soluble. Therefore, it is considered a weak base. Question number 2, why is HF not a strong acid? Here's a hint. Fluorine is the most electronegative atom, therefore HF bond is very strong. Therefore, it's very hard to dissociate the HF bond, so therefore HF is a weak acid. For practice number 1, draw how bright the light bulb would be. Pause the video and resume as completed. Here are the answers. Question number 1, which is an acid or base in the Ford reaction, HF or H2O? If you look at this chemical equation, HF is losing a hydrogen ion. Therefore, it is an acid, while water is gaining a hydrogen ion. Therefore, it is a base. Which is the acid or base in the reverse reaction, F- or H3O+? In the reverse reaction, fluoride is gaining a hydrogen ion, while hydronium is losing a hydrogen ion. Therefore, hydronium is the acid and fluoride is the base. This is known as the conjugate acid and base pair. This is from the Bronston-Lowry theory. Products of acids and base reactions are called conjugate acid and conjugate base. Here's a diagram to illustrate this. Conjugate acids and base pairs are compounds that differ by presence of one proton or H+ ion. Conjugate base has one less hydrogen ion. Conjugate acid has one more hydrogen ion. Strong acids and strong bases have weak conjugate acids and bases. Learning check number 4, which pair represents an acid and its conjugate base? Pause the video and resume as completed. The first step is to figure out which substance in the chemical reaction is behaving like an acid. That would be HSO4- because it loses a proton during the reaction. The conjugate base will have one less proton, therefore the answer is choice 1. Learning check number 5, the conjugate base of HSO3- ion is what? Pause the video and resume as completed. The conjugate base has one less proton, so the answer is choice 3. Another way to think about it is that HSO3- will behave like an acid in this situation. Therefore, it will lose a proton. For practice number 2, identify the acid, base, conjugate acid, and conjugate base. Pause the video and resume as completed. Here are the answers. For practice number 3, complete the table. Figure out the conjugate acid and conjugate base. HBr is a strong acid. Therefore, when it loses a proton, it becomes Br-, which is the conjugate base. There is no conjugate acid because HBr is a strong acid. It will not behave as a base. For H2O, it is amphoteric. It can act like an acid or base. So depending on the situation, water can have a conjugate acid or a conjugate base. To get the conjugate acid, waters can behave like a base and lose a proton. So the conjugate acid is hydronium, which is one more proton than water. To get the conjugate base, waters can behave like an acid and lose a proton. So the conjugate base of water is hydroxide, which is one less proton than water. Let's look at the next one. This is acetate ion, which is a polyatomic ion on table E. To get the conjugate acid, acetate ions can behave like a base and gain a proton. Therefore, acetic acid is the conjugate acid of acetate ion. What is the conjugate base? Can acetic ion lose a hydrogen ion? Let's analyze the Lewis dot diagrams. This is acetic acid. This is acetate ion. This hydrogen represents this hydrogen here, and these 3 hydrogens are bonded to carbon. Would acetate ion lose these 3 hydrogens to form the conjugate base? The answer is no, because CH is a nonpolar bond. Therefore, it will not dissociate. So there is no conjugate base of acetate ion. The next one is sulfuric acid. Sulfuric acid has no conjugate acid because it will not behave like a base because it's a strong acid. The conjugate base of sulfuric acid will be HSO4-. Here's a tip to help you solve some of these questions. Typically, if you see a polyatomic ion with an H in front, it can have a conjugate acid and a conjugate base. The H has to be the first element. So HSO4- is a polyatomic ion with H in front as the first element. It can have a conjugate acid and a conjugate base. To get the conjugate acid of hydrogen sulfate ion, it will behave like a base and gain a proton to become H2SO4. To get the conjugate base, the hydrogen sulfate ion will lose a proton and become sulfate ion. For sulfate ion, it is a polyatomic ion with no hydrogen. Therefore, it cannot lose a hydrogen to get the conjugate base. It can only gain a hydrogen to get the conjugate acid. Try to do the rest of the questions by yourself. Pause the video, resume as completed. Here are the answers. When looking at practice number 3, you may have noticed that some substances can donate or accept more than one hydrogen ion. So let's analyze the difference between monoprotic and polyprotic. Mono means one, protic is referring to proton or H+ ions. So monoprotic acid can only donate one proton per molecule. Here are some examples. They are binary acids. Monoprotic base can only accept one proton or have one hydroxide per molecule. Here are some examples. Poly means many, so polyprotic acid means it can donate more than one proton per molecule. This was the example in practice 3. Polyprotic base can accept more than one proton or have more than one hydroxide per molecule. Normality is the unit of concentration that counts for the active ions in acids and bases. Normality is the molarity times the number of hydrogen ions or hydroxide ions in the acid or base. Let's look at an example. What is the concentration of H+ in 1 molar HCl? Since there's only one active hydrogen in HCl, the molarity is 1 molar H+. You can also represent it as 1N of HCl. What's the concentration of H+ in 1 molar H2SO4? Notice there's 2 active hydrogens in sulfuric acid, so there's 2 molar of H+ ions. You can represent this as 2N of sulfuric acid. Try to do the check of understanding yourself. Pause the video and resume as completed. Here are the answers. This concludes the video lesson. Remember to do the Juniper homework and quiz.